Let's talk networks, the invisible backbone of our digital lives. Whether you're at home, in a bustling office, or even at your favorite coffee shop, networks are quietly working behind the scenes, connecting us to information, entertainment, and each other. They're so fundamental that we often forget they're even there, until something goes wrong. Right now you're using one to read this. Every website you visit, every message you send, and every video you stream relies on a network to make the magic happen. It's the digital thread that ties our devices and our lives together. A network is just a bunch of devices, PCs, phones, smart gadgets, all linked to share data and resources. Imagine your phone sending a photo to your laptop, or your smart TV streaming your favorite show. That's your network at work, making sure everything talks to each other seamlessly. Think of it as a digital neighborhood, where instead of borrowing sugar, you're streaming movies or teaming up for a LAN party. Your devices are like friendly neighbors, always ready to share files, play games, or help you get work done. But how do these digital neighbors communicate? It's not just about being in the same room, there's a whole system of connections and pathways that make it possible for your devices to exchange information quickly and securely. But these devices don't just talk to each other by magic. They need physical connections and hardware to make it happen. Whether it's a tangle of cables under your desk or invisible Wi-Fi signals in the air, something has to carry your data from point A to point B. Network hardware, cables, cards, antennas are the roads and bridges for your data. They're the unsung heroes, making sure your emails, videos, and games get where they need to go fast and reliably. Without them, your computer is an island, cut off from the world. No matter how powerful your device is, it's only as useful as its ability to connect and communicate. Each piece of hardware has a specific job, from simply extending a connection to making complex decisions about where data should go. Switches, routers, hubs, they all play unique roles in keeping your network running smoothly. Some devices act like traffic controllers, directing data to the right destination, while others simply pass information along. Understanding who does what is key to building a network that's fast, secure, and reliable. Understanding these components is the first step to fixing lag or printer issues and building a reliable setup. When you know what each part does, you can troubleshoot problems and even upgrade your network for better performance. So let's break down the essential hardware. What you need, what each device does, and how they all fit together to create a seamless digital experience. We'll start with the basics, from old-school hubs and repeaters that simply pass data along, to more advanced gear. Then, we'll look at the smart switches and routers that run today's networks, making decisions in real time to keep everything connected and secure. By the end, you'll know exactly what those blinking lights mean, and you'll be ready to start building your own network, one connection at a time. Let's start simple. Repeaters and hubs. These are the most basic building blocks of a network, and understanding them is key to grasping how data moves from one place to another. Imagine you're trying to send a message across a vast field, but your voice can only carry so far. That's where repeaters come in. A repeater is like a helpful friend standing halfway across the field, ready to catch your message and shout it out again, making sure it reaches the other side. In networking terms, a repeater takes a weak or fading signal and amplifies it, so your data can travel much farther than it could on its own. This is especially useful when you need to extend your Ethernet cable's range beyond its standard limit, usually about 100 meters. Without a repeater, your data would simply fade away and never reach its destination. The repeater doesn't analyze or interpret the data, it simply copies and strengthens whatever it receives, whether it's a file transfer, a video call, or just a simple email. It's a straightforward device, but absolutely essential for larger networks. Now let's talk about hubs. Think of a hub as a repeater with extra arms, more ports for more devices. It's designed to connect several computers or devices together in a single network segment. When you plug in multiple devices, the hub doesn't try to figure out who should get which message. Instead, it simply broadcasts every message it receives to all connected devices. There's no intelligence or filtering, just brute force communication. It's like shouting in a crowded room. Everyone hears everything, even if the message is only meant for one person. This can quickly become chaotic as more people join the conversation. The result? A lot of unnecessary network traffic. Every device has to listen to every message, even if it's not relevant, which can slow down the entire network, especially as more devices are added. Only one device can talk at a time. If two devices try to send data at once, their messages collide and get lost, forcing them to resend and causing even more delays. Hubs are simple and inexpensive, making them a popular choice for small or temporary networks. But they lack the intelligence to manage traffic efficiently, which means they're not suitable for larger or busier environments. As networks grow and more devices are added, this everyone hears everything approach quickly becomes a major bottleneck, leading to slowdowns and frustration for users. That's why hubs have mostly disappeared from modern networks, replaced by smarter devices that can direct traffic more efficiently and keep things running smoothly. Let's see hubs in action. Imagine 4 office PCs plugged into a hub. When PC1 sends a file to PC4, the hub blasts the data to all ports. Everyone hears it, even if it's not for them. Hubs operate at the physical layer. They don't read addresses, just amplify and forward signals. This creates a collision domain. All devices compete for the same bandwidth. If 2 PCs send data at once, their signals collide and both messages are lost. Devices must wait, then try again, slowing everything down. The more devices, the more collisions and the slower the network. Bandwidth is shared. 10 PCs on a 100 megabits per second hub don't each get 100 Mbps, they share it. Only one can talk at a time. That's why hubs are obsolete. They're simple but inefficient. Modern networks need something smarter. Enter the switch. At first glance, switches might look just like hubs, plain boxes with lots of ports and blinking lights, but don't be fooled by their simple appearance. Inside, switches are far more intelligent, acting as the brains of your network. Unlike a hub, which simply repeats everything it hears to every device, a switch is more like a skilled postal worker. It carefully reads the address on each data packet and delivers it only to the right recipient, keeping the rest of the network quiet and efficient. Every device on your network has a unique MAC address, almost like a digital fingerprint. This address is how the switch knows exactly where to send each piece of data. As devices communicate, the switch quietly builds a table, learning which MAC address is connected to which port. This learning process happens automatically without any extra setup from you. So when PC1 wants to send a file to PC4, the switch checks its table and sends the data only to port 4. No unnecessary traffic, no wasted bandwidth. This targeted delivery means no more broadcasting to everyone. Only the devices involved in the conversation get the data, making the network much quieter and more secure. Each port on a switch becomes its own collision domain. That means multiple devices can send and receive data at the same time, without their signals interfering with each other. The result? Every device gets its own dedicated bandwidth, so everyone enjoys fast, reliable connections, even during busy times. On a 100 megabits per second switch, each device truly gets a full 100 megabits per second connection, not just a share of the total speed. This is a huge leap from the old days of hubs, where everyone had to split the bandwidth. No more sharing, no more collisions, and no more slowdowns when multiple people are online. Switches keep everything running smoothly. Switches make networks not just faster, but also more efficient and scalable. As your office grows, you can add more devices without worrying about network congestion. That's why switches have replaced hubs in almost every modern network. They're simply better in every way. Smarter, faster, and more reliable. If you want a smooth, modern network that can handle today's demands, you need a switch. It's a true game changer for any business or home setup. Let's break down hubs versus switches. Hubs are dumb. They just repeat signals to all ports operating at the physical layer. They don't read addresses or manage traffic. Everyone shares one lane and collisions are common. Switches are smart. They operate at the data link layer, reading MAC addresses and forwarding data only where it needs to go. This isolates traffic, making the network private and efficient. Hubs run in half-duplex devices can only send or receive, not both at once. More devices mean more collisions and slower speeds. Switches provide dedicated bandwidth and full duplex devices can send and receive simultaneously. A 1 Gbps switch gives each device a full 1 Gbps connection. That's why switches scale and hubs don't. Today, if you're connecting multiple devices, you're using a switch. It's the backbone of every modern wired network. Hubs are history. Now let's go wireless. A wireless access point, or DAWAP, lets Wi-Fi devices connect to a wired network, no cables needed. It's a bridge, translating radio signals from your phone or laptop into data for the wired network, and vice versa. The WAP broadcasts a network name, SSID, connect with a password, and you're in. All devices on a WAP share the same wireless bandwidth, so heavy use can slow things down. Your laptop sends data as radio waves to the WAP, which converts and forwards it over Ethernet. The process reverses for incoming data. A WAP is not the same as your all-in-one home router, it's just for wireless access. In larger spaces, you might have several WAPs for full coverage. Most home routers combine WAP, switch, and router in one box. Knowing the difference helps you build a better network. How does your device join the network? With a network interface card, or NIC. The NIC is the translator, turning your computer's data into signals for the network, wired or wireless. Every device has a NIC, whether it's a desktop, laptop, or phone. For desktops, it's often a card or built-in port. For laptops, it's integrated. The NIC handles sending and receiving, using MAC addresses to identify itself. Indicator lights on the NIC help troubleshoot connection issues. Speed matters. NICs come in 1, 2.5, 5, or 10 Gbps versions, but your network is only as fast as its slowest part. For wireless, it's a Wi-Fi adapter rated by standard, like Wi-Fi 6 or 7. The NIC is the foundation of your device's network performance. Switches and WAPs connect your local devices, but what about the internet? That's the router's job. A router connects different networks, your LAN to the internet, using IP addresses. Think of the switch as the office mailroom, and the router as the city's post office. The router uses a routing table to decide where to send data packets beyond your local network. It's the gateway, security guard, and traffic director for your home or office. Most home routers combine switch, WAP, and router in one device. Without routers, the internet would just be millions of isolated networks. The router is the key to global connectivity. Let's recap. Repeaters and hubs extend and connect but are outdated and inefficient. Switches bring intelligence and speed, making modern networks possible. WAPs connect us wirelessly, while NICs let devices join the network. Routers link local networks to the internet, directing traffic worldwide. Each piece has a unique role, working together to keep us connected. Understanding these basics empowers you to build, troubleshoot, and upgrade your network. Next time you see those blinking lights, you'll know exactly what's going on.